Alright, let's take a look at Nemesis. So I've remoted into one of the systems that we're looking at here. It's 192.168.1.60. The other target is 192.168.148. So let's go ahead and ping that guy. 192.168.1.148. Okay, we've got that. We'll do an arp minus n. Sorry, arp minus a. And there's our information that we're looking for right there. So what I'm going to go ahead and do is I'm going to ping that guy. Continuously. And we're going to come back and take a look at this here in a minute. Now if I needed to clear this in Windows, it's pretty easily. Minus D and then an asterisk will clear the ARP table. And there's the device we're communicating with again. All right, so let's go ahead and take a look over here at our Nemesis system. So I'm going to go ahead and use TCP Dump, and I want to source only traffic from 192.168.1.148, and I want to do ICMP. So I'm going to go ahead and start that running. And that really shouldn't do anything for us. Okay, now I'm going to go ahead and cycle back up through this so we can take a look at these two commands. So here's our Nemesis command, and basically what we're telling our remote systems here is that the addresses of the opposite end of the communication is actually us. So the MAC address here at -H, no little h, and ending in F1 and capital H ending in F1 are my MAC addresses. And the addresses here at -M ending in 56 are the 148 addresses. So we're going to tell anything that is going from 60 to 148 that it needs to go through us. Now here's the other command that goes with it. So the first one was .60, the second one was .148. What we basically did here is reverse the entries here in our -M and -M entries here. As the book shows, we have us doing this command, which is basically here it is. So while true, do sudo nemesis arp -v -r and the whole thing. Okay, we're going to go ahead and sleep, and then we'll be done. So let's go ahead and start that, and let's take a look at what happens. It takes it just a little bit of time here, and we should start to see, boom, we've already re-injected packets. So we are now listening to traffic that we should not be able to listen to. So if I come back over to this other system here, we notice that our MAC addresses let's take a look at another tool here now that we've taken a look at Nemesis. Nemesis is great, but it requires a lot of building of the commands, a little bit clunky to use. So there's another one, Arp Spoof. Fairly easy to use and does the exact same thing relatively quickly. So I've already started my PCAP again. I've cleared out everything on my other system, and we're going to go ahead and do the exact same thing. So the command line for this is sudo arpspoof -I ethernet 0 -T is my target. Who do I want to spoof from, and what or the destination, and this host. So this is pretty much the exact same command, a lot easier. I don't have to do any bash scripting to get this to work. And I go ahead and hit it, and boom. Right, we already see that we're already starting to get these ARP replies. So as soon as that caches on the remote system, it'll take a few seconds here for that to occur. We're once again injecting. So we can take a look at our other system, and we can take a look at, we'll notice that that entry has changed for us. So now we're actually able to intercept that traffic. And we can do some other cool stuff here with this. So I'm going to go ahead and stop this. We're going to go ahead and take this to the next level. Alright, let's take this to the next stage. I'm going to go ahead and do the same thing. Monitor traffic from 192.168.1.60 from my attacker machine. As you can see, I've got this guy pinging a couple different things. I've got him pinging .148, and I've got him pinging 4.2.2.2, so some internet traffic. I'm going to go ahead and use Arp Spoof again, and I'm going to go ahead and change it a little bit so that I'm targeting my default gateway, which is 192.168.1.1. As you can see right now, I'm not pulling in any traffic. Going ahead and hit that, and as soon as I do that, you can see that I'm immediately hitting ICMP redirect traffic, which is very, very cool. So I'm man in the middle, my gateway redirecting traffic through me. And in Linux, it does require you to go ahead and have the IP forwarding enabled, which I've already done on this machine. So we're good to go with that. So let's go ahead and stop that attack. And the last thing I want to go ahead and show you is a slightly different type of attack. This is a slight modification of a denial of service attack. Pretty easy for us to pick up as a network engineer. Somebody's going to see this monitoring the switch. But let's take a look at some statistics that we have here. So here's our MAC address table. And you can see we've got some entries in here. But let's take a look at our count. So basically we've got a little over 8,100 MAC addresses that we can have available on this switch. So we can go ahead and do the same thing. We can listen for .60 or for .148 traffic. Let's go ahead and do that. We'll change this to 148. So we should be seeing back any replies that we're going to have, which is going to be this guy. I'm going to stop this one. It's unnecessary. And we're going to go ahead and run a different tool here. The Macof tool, we're going to go ahead and tag our default gateway again. Just some destination address. What this tool does is allow us to flood the MAC address table on a switch with MAC addresses. So we'll bring this up, we'll take a look at it. We're going to watch this number dramatically decrease. So let's go ahead and do that. We see that our count is decreasing. We're not getting any new data yet. Alright. We've completely exhausted the total number of dynamically learned IP address, or excuse me, MAC addresses that we can get on the switch. I know that this switch has this Now we'll notice I'm starting to see some traffic now on my capture. What has occurred here? So we go back and we take a look at this. We're still maxed out. And we can see that our MAC address table is completely flooded, all right, with all these entries. but we are intercepting this traffic. What we've caused to happen here is we have forced the switch into hub-only mode. So when it reaches its maximum allotted dynamically learned MAC addresses, anything else that comes into the switch to afford functionality automatically goes into repeat mode. Very, very cool. Very obvious for us to detect, and depending on your port configuration, port security would mitigate this for you. Unfortunately, you have to be able to lock that down to a single MAC address communicating. Because I'm running on a VM that's in bridge mode, I've got multiple MACs I need to be able to communicate with. So I won't be able to lock that down in this instance. Well, that's it. That's my demo. Thank you very much for watching.